this session we'll be covering what are functions, how functions are structured. We will be doing some example to understand we write a function. We'll be drawing some conclusion based on the examples that we have discussed. We'll be writing some code and solving some problem. And at the end of the session, I'll be giving you some exercise questions that you can write on your own so that you can get more understanding on functions. So let's begin with what are functions. Functions are self-contained block of statement that perform coherent tasks of some kind. So you can assume function as a entity in itself, a small piece of code in itself which is complete. That piece of code will expect some input and will give you some output. So assume a program is kind of building some blocks, and each and every single block is a function. So a program consists of multiple functions. So each block has a specific task, and when we fix all the blocks, we'll complete our program. So that means if you frame it in a coding way, a function is something which tries to do some job which has been delegated to it. So functions are one way of doing delegation. So for example, if you can see this figure, in this example I have taken a calculator example. Suppose there is a function called calculator, and calculator can perform add operation. So in our main method will delegate some operation, say hey calculator, add me 4 and 5 and send me the result. So main method just delegates the responsibility of adding 4 and 5 to the calculator. Calculator finds it out, okay, I can delegate this to add method. So calculator delegated this responsibility to method called add. Add will perform actual addition, return back the result to the calculator. Calculator will then return back the result to the main function. So this is a very simple and very illustrative example of how we use a function and what is the role of function in a program. So here main method is delegating its responsibility to calculator. Calculator is delegating its responsibility to add method. Add method actually does the operation and then return back the result to calculator. Calculator then return the result back to main method. Function also helps writing a very cleaner code. So for example, if you have some piece of code where you want to perform you want to execute that piece of code again and again, so instead of copying those piece of code multiple times in your program, you just write a function that has those piece of code and call the function again and again. So this makes the code very cleaner and easy to understand, and also it helps in easy to debug and easy to fix the bugs in case suppose those piece of lines which we are copying again and again has some bug, and if we find out some issue and we try to fix it, if we are not using function, we have to fix in each and every block where we have copied the code. But if we write the function, we just have to fix in one place and the result will be reflected everywhere wherever we are using the function. So functions are very helpful, and more or less you will see any program which is having a small set of logic will have at least one function, because in larger scale we cannot assume a program without a function. So how functions are structured? Every function has a function name, a return type, parameters, and function body. So this is how the function is written. And function will have a return type, function will have a function name, it will have some parameters and a function body. So parameters are the input to function, return type is the output of the function, and this is the function name. So function name determines, basically you need to give some meaningful name to function, so that when we are using a function, we should know that this function will be performing a certain task. So it's a good practice if you use it. So let's do some more illustration on this. Return type. A return type is a function may have a return value. A return value is a data type of value the function returns. For example, in this function is the add numbers is returning an integer data type. So the return type is a kind of data type. Some functions perform desired operation without returning a value. In this case, the function should return void type. So it's not always necessary that function should return something. There could be some logic where you just perform some function and don't expect anything returned from the function. In that case, function will have a void type of return type. Function name. This is the actual name of the function. The function name and parameter list together constitute the function signature. So basically, function and function parameter combination will should be unique. So if we have two functions with same name and same type of parameter, then we'll be getting some compilation errors. And as I have already said, function name should be self-explanatory. Parameters are like placeholders. When a function is invoked, you pass a value to parameter. This value is referred to as an actual parameter or argument. Parameter list refer to the type, order and number of parameter of function. Parameters are optional, that is function may contain no parameters. So parameters are nothing but the input that you give to the function. It could be possible that your function does not accept any value, and in that case the function we say it is accepting a void type, and if any function is not accepting any value or void type, we can leave it empty. We don't have to give anything in the open and close brackets. So that will work just fine. Function body contains all the collection of statements that define the what function does. So your whole logic, what you are doing in a function will be present in the function body. Okay, let's see this example. Again, this example is whatever we have discussed in this slide: the main method, the calculator method, and the add method. So here we have a main method, we have a calculator method which is declared here, defined here. We have add method which is declared here, defined here. So this is function declaration, this is function definition, this is also function definition. So here we are defining add method, here we are defining calculator method, here we are declaring both the methods, and here we are calling the method. So let's do a dry run of this program. We are calling a main method, int a equal to 5, b equal to 6. Then we are calling result equal to calculator a, b and 1. So this will call a method called calculator. Calculator will have 3 arguments: a, b and type of operation you want. In this case, we are having only one type of operation. So it will check if operation is equal to 1, then it performs add. So calculator again call add, and this will say add AB. Add method will be invoked, and add method will return the result of a plus b. A plus b will be returned to calculator, and calculator then return this result back to the main method, and main method will print the result. So this is how the flow works. So let's draw some conclusion out of it. Any C program can contain at least one function. So it's not mandatory that you should have a function, but it is good practice to use functions so that your program will be well structured and it will be easy to maintain and easy to debug. Uh, so it's you should try to use functions. If program contains only one function, it must be a main function. So if a program contains only one function, then it has to be a main method. More than one function, then main plus some other function. If a C program contains more than one function, then one and only one of these function must be a main function, because program execution always begin with main. So this is self-explanatory. There is no limit on number of functions that might be present in C program. So yeah, we can have a lot of functions in a C program. Each function in a program is called in sequence specified by function calls in main. So the calling of function will be driven from the flow that starts from main. So in this example, we have called the calculator method. The calculator method is called the add method, and it ends here. So the flow is like main method will call calculator, calculator calls add. So this is the flow, because it originates from the main method. Each function in a program is called in sequence specified by the function call in main, that we have just covered. After each function has done its control, returns to main. When main returns out, the function call ends the program. So each function returns the control to main. Here in this example, uh, once this add method is done, it returns a control to the caller method, which is calculator, and calculator will finally return to back to main. So whatever sequence of function, whatever chain of function that we are calling, ultimately it ends up to main. So this is how, because the function call originates from main, so it has to end to main. Okay, so let's write some program so that we can have more and more understanding on how C function works. So let's begin with writing some code. Okay, let's take one program. Write a function is even, which will check if a number is even or odd, and returns 1 if the number is even and 0 if the number is odd. So let's try to write the code for this. Okay, let me create a file. Let me give function1.c program to find if number is even or odd using function #include stdio.h in the main. Return 0. Okay, let's have some numbers, say n. Printf, enter the number. Okay, let's do the scanf. %d ampersand n. Okay, so let's declare a function here. Int is even. It will take a number. Okay, so let's define the function is even is. Okay, so what it will do, it will return if num percentage 2 equal to 0, so it will return. So if function is divisible by 2, it will return 1, else it will return 0. Right function is even, which checks if the given number is even or odd, and returns 1 if the number is even and 0 if the number is odd. So perfect. So in this case, if the number is 0, that means if number percentage 2 is equal to 0, that means it is an even number. We'll be returning 1, else we'll be returning 2. Okay, now printf. Let's have percentage d is of type percentage d. Okay, so number for n is of type is even n. Okay, so let's save it. Let's compile it. gcc -o. So the code is compiled perfectly. Let's run it. Enter the number. Let me give 4. 4 is of type 1. Okay, let me give /n after we print the result so that it is more clear. Okay, let me run again. Enter the number. Let me say 5. So 5 is of type 0. 0 means the function, in case of if the number is odd, it will return 0. If the number is even, it will return 1. So we are getting the correct result. 5 is of type 0, that means it is odd. Let me run it again. 4 is of type 1, which is even. So we are getting a correct result. So this is how function works. So as you have seen, I have called function here in a printf statement. So we can do that. We don't have to declare any variable and store it and then do some operation. We can call directly here. So once this statement is executed, first this method will be executed and the value will be placed here, and then finally the printf will be executed. Let's do one more example. I write a function to calculate the simple interest. So what is the formula for simple interest? For simple interest, it is principal into rate into time by 100. Let's write the code. Let's see. Program to calculate simple interest. Hash include stdio.h and main Okay, let's declare the method. Simple interest and principal and rate and time. Okay, let it return a float value. Okay. Let us define the function. Principal and rate and time. So float interest equal to P into R into T by 100. Return interest. Okay, let's take the variables P, T, R. Enter principal, scanf, percentage D and percent P, printf, enter rate of interest, scanf, percentage D and percentage R, printf, enter time, scanf, percentage D and percentage T. Okay, then I'll say printf is percentage F simple interest VRT. Okay, where we are making interest rate as float, but all these are in integers, so we need to do the data type casting. So this is how we can do data type casting. We will be converting this to float so that the calculation will result in a float. So here, as you have seen, I have we are calculating PRT and I am typecasting it into float. 100 is typecasted into float type. So whatever result we get, that will be of floating type. So let's compile it again. Let's run it again. I'll give the same input. So this time, this is what a simple interest we are getting. So let's do one more example. Write a function to print the first n numbers of a Fibonacci series. So what is a Fibonacci series? Fibonacci series is a special series where the first number is 0, second number is 1, and the third number is starts with the sum of previous two numbers. So third number is equal to sum of first number and second number. Fourth number will be equal to sum of second number and third number, and so on. So let's write a code for this. Okay. program to print an first and Fibonacci number. Okay, hash touch and main times 0. Let me declare the function. So here we will be declaring a void type because we will be printing the number. So we will be not returning any result. Fabo, and let me give this let me write this function, and let me uh, define this function. So int first equal to 0, equal to 1. So in case if n equal to 0, sorry 1, or printf percentage d, let me say if n is greater than equal to 1. Okay. If n is greater than equal to 2, so we'll first I'm declaring two variables, and first is equal to 0, and second is equal to 1. So in case if n is greater than equal to 0, that means I have to print first percentage d. Okay, if n is greater than equal to 2, I need to print second percentage d, second, n is greater than 2, that means we have more numbers, then let me define a variable temp. I mean in case where n is more than 2, greater than 2, then we need to write some loop. So for say, let me take one more variable, say I, for I equal to 3. Why we have taken I equal to 3? Because we have already printed the first two numbers. So first the n equal to 1 is over, n equal to 2 is over. Now we have to do n equal to 3. So while for I equal to 3, I less than equal to n, I plus plus. Why I less than equal to n? Because we need to go till n. Okay. Now temp equal to first, second. Okay. Previous two numbers. Then we'll be doing printf slash n percentage d temp. So we'll be printing the sum of previous two numbers. Then we'll be reassigning first and second. So first equal to second and second equal to temp. So first will become a second and second will become temp. Temp is like third number. So the loop will continue. So let's do a dry run of this. So if we suppose we get n equal to say 4, so we'll be initializing first as 0, second as 1, and all these things. And now n is 4, so 4 is greater than or equal to 1. Yes, the condition is true. We'll be printing 0, which is first. Now this condition will be executed. 4 is greater than equal to 2. Yes, correct. So we'll be printing 1. Now this condition, whether 4 is greater than 2. Yes, 4 is greater than 2. Now what we'll be doing is for I equal to 3, I is less than equal to 4. Yes, it is correct. I plus plus. Now temp equal to first plus second, that is 0 plus 1. So temp will become 1. We will be printing 1. Okay, so now first will become second. That means first variable of first will become 1. Second will become 1, and again we continue. I equal to I will become 4. 4 is less than equal to 4. Yes, it is correct. We'll go inside the loop. Now temp will become 1 plus 1, which is equal to 2, and we'll be printing 2, and first will become 1, second will become 2. So in this case, if n is given as 4, we will be printing 0, 1, 1 and 2. So, okay, so let's call this method in the main function. Let's take an input from user. Let's do scanf. Okay, now let's call this method. Okay, so here once when we call this method, the Fibonacci series should be printed. Let me compile it again. Let me run it again. I'll be giving 4 again. So here we'll be printing 0, 1, 1, 2. So now let's run it again. Let me give say 0. It will not print anything because we don't want any. So this is our corner case that we have checked. So we are getting correct output. Let me give a negative number. Yes, we are not encouraging or we are not accepting any negative number. Let me give some value, say 100. So we are getting this number. So 100 will result to a very large number. So instead of integer, we we might have to use an unsigned integer or unsigned long. So I'll be this will be your exercise question, so that just in case when we give 100 as a Fibonacci number, just try to print try to use the data type which can fit in the number and print it. Okay, so these are the exercise questions that you can do on your own, which is very simple. Write a function to print a given number in a reverse order. For example, you are given 1 2 3 4 and you need to print it in a reverse order, 4 3 2 1. So all you need to do is you need to use a modular function, modular operation, and you will be easily able to do this. The second question is write a program to convert a temperature from Celsius to Fahrenheit. So this is also very easy. You can find the formula and convert. This is nothing but doing some mathematical calculation, but you need to write it in a function so that you can use it multiple times anywhere, any way we want. Okay.
I'm sure you enjoyed learning from this video. Please like the video, and if you have any doubts regarding this video, please comment us in the comment section, and don't forget to subscribe to our channel for more such informative videos. Do look out for other related videos in our playlist. For more information, visit our website now. Keep learning with Intellipaat.